I mentioned earlier that there are actually three measures that we can look at when we're trying to find associations. One was support that we've already looked at. The other two are confidence and lift. So we're going to talk about confidence right here. The confidence is basically asking how likely is a certain item purchased when another item is also being purchased at the same time. So specifically, how likely is a certain item Y purchased when another X item is also being purchased? So here's how we find this confidence. By the way, on the left-hand side of this formula, you see confidence and then X and then kind of like a little arrow pointing to the Y. And you kind of almost would want to read that backwards and say, that's asking for how likely is it that Y will be purchased given that X is also being purchased. Okay, so you start with the second one and then say the first one. So again, how likely is it that Y will be purchased given that X is also being purchased? And the way we find that is we take on the top of the fraction, we have the number of transactions including both the X and the Y, and then we divide that by the number of transactions including X. So for the bottom one, we're not looking at the total number of transactions like we've done before. We're looking at just the number of transactions that involve whatever the first item is that's mentioned in what we're looking for. So if we're looking for the confidence B and then the arrow to C, that's how likely is it that C is being purchased given that B is already being purchased. Okay, so we'd have the number of transactions with both B and C and divide that by the number of transactions including just worrying about looking at the B. Okay, so there were 2 transactions with both B and C, and 3 transactions have a B in them. So our confidence for that would be 2 divided by 3, which is 66.7%. For this one, this is the confidence of E given A. So how likely is it that E will be purchased given that A is also being purchased? So the formula is number of transactions including A and E divided by the number of transactions just including A. And that would be just the A and E, there's only one of those transactions. So we'd have 1 divided by, and then 2 transactions include A. So 1 divided by 2, which is 50%. Now here's the confidence that A is being purchased given that E has also being purchased. So notice those are the same letters, A and E, but this time it's backwards than what it was right above. So we're not going to necessarily get the same answer at all. So we would take the number of transactions including A and E, which again, there's just one of those, but divide it by the number of transactions including E. Now there's 3 transactions including E. So it would be 1 divided by 3, which is 33.3. Now confidence does not account for the popularity of the second variable mentioned, okay? If we're talking about confidence, X arrow to Y, meaning how likely is it that Y would be purchased given that X is purchased, then confidence does not account for the popularity of Y. Because if Y is very popular in general, then there's going to be a higher chance that any transaction including X to begin with also will contain Y, because Y is just popular in general. So, and don't worry about this too much, hopefully you can kind of see what I'm saying, but the point is that confidence is not something by itself that that we can really use too much, because again it depends on really the popularity of what we're looking at in terms of what we're going to get. So anyway, but just don't worry about that. Just know how to find the confidence of any two items. Now let's talk about lift. So with lift, it's kind of the same idea. It measures how likely a certain item Y is purchased when another item is also being purchased. That's exactly what confidence was, but the difference is it takes the popularity of item Y into account. So the problem we just saw with confidence is no longer around for lift. So it's going to take into account the popularity of one of those items and then give us, so this is something that's more meaningful that we could actually use in more reliably than confidence. The way we find the lift is of X and then arrow Y, which again we would write as, we would say the lift of Y given X. It's the support of X and Y divided by, and then the support of X times the support of Y. Now notice in that fraction, the bottom part of the fraction is in parentheses. So that support X times support Y, that's the entire bottom. So it's not like we're going to just have the support of X on the bottom. We actually have support of X times the support of Y. That's the denominator for this formula. So the lift of C given B would be support of B and C divided by support of B times the support of C. What we would get if we look at that, and hopefully you remember how to get the support, you'd find all of those individually and then put that into the formula and you would get 0.889. For lift of buying E given B would be support B and E, and then divided by the support of B times the support of E, and we would get 1.33. This is the first time we've had anything bigger than 1. For support and for confidence, it's always going to be under 1, but lift is something different, and we'll talk here in a minute on what lift is going to tell us. But this lift value is 1.33. Okay, what does this mean? A lift value greater than 1 means that the item Y is likely to be bought if item X is bought, while a value less than 1 means that item Y is unlikely to be bought if item X is bought. So let's look up back on lift B, this first example, lift B arrow C. Okay, that is the support is less than 1. So we would say that a value less than 1 means that item C is unlikely to be bought if item B is also being purchased. Okay, so just try to remember that. It's just the likelihood of the second one being purchased given the fact, you know, if the other one is, okay, so sorry. So the lift is just basically saying the likelihood. Is it likely or unlikely? So if it's greater than 1, it's likely, and if it's less than 1, it's unlikely. Here's another example. I've taken it from an article that you see posted right there. We have 5 different shopping carts, and they all include different combinations of 5 different items. And what we're going to look for is finding the support, confidence, and lift for these different rules here. Okay, on the left, on looking in this little chart here on the left, it said the first rule here would be D purchased given that A is being purchased. Okay, remember we're reading from the right to the left. D purchased given that A is purchased. The second one down, A purchased given that C is purchased. Third one down, C is purchased given that A is purchased. And then there's another one at the bottom, D is purchased given that B and C are also purchased. So we're going to find the support, confidence, and lift for all of these. Now, if you look over to the right, you see this, I took this straight off of this website. So they talk about their formulas look a little different than the formulas that I wrote down. I mean, it's the very same thing, but they just use some different notation. So when they say FRQ, that means how many transactions have both X and Y in them. And for N, capital N, that just means the total number of transactions. Okay, so hopefully you see that it's the same thing, it's just the different notation. Okay, so let's first of all look at the support for A and D. When it comes to support, it doesn't matter which order the two are in. Okay, so support, just how many have both A and D in them? Well, we'll look at the shopping carts and find that there's 1, 2. There's 2 of them out of possible 5, so 2/5 support. Okay, looking at support for C and A, again, just the order doesn't matter for support, just how many have A and C together. So 1, 2, looks like just 2, so 2 out of 5. And for support, C and A, it's the same thing as the one right above it, because again, with support, the order doesn't matter. So again, A and C, 2 out of 5. Let's look at the last one. What's this support of B and C along with D? So basically, we're just going to count how many baskets have B and C and D in them. So B, C, and D, there is one basket that has all B, C, and D, and none of the other baskets have all 3 of those. So it would be 1 out of 5. Okay, now let's look at the confidence. So if you look at the formula for confidence, you see that the over there on the right, the numerator is the same for support and confidence. The difference is the denominator. Instead of total number of transactions, it's just the frequency of how many have the first one mentioned. Okay, how many have just that first one mentioned in there? So for the confidence for this first one, D given A, we would look for how many with D and A. And D and A, there are 2 of those, and then divided by how many just have the A. Okay, so the denominator for the confidence is how many have that, the first one mentioned. So there are 3 baskets that have A in there. Okay, now confidence for A given C. How many just have A and C in them? 1, 2, just 2. And then divided by what's going to be the denominator. Again, remember, for confidence, that's just how many have that, the first one mentioned, which is the C. How many have C in it? 1, 2, 3, 4. So 4 is the denominator for that one. So 2 over 4, of course, that will simplify to 1/2. AC, now this is going to be different here. Just because they have the same 2 letters doesn't mean they're the same when it comes to confidence, because the denominator is going to be different here. So again, though, the top would just be how many have both A and C, and there's 2 of those. And then the denominator is how many have A. And so we'd say 1, 2, 3. 3 of those have A. So 3 is on the bottom. So 2 out of 3 is 2/3 is the confidence for C given A. Now the confidence for D given B and C. So that would be how many have B, C, and D. So there's just one that has B, C, and D, so that the numerator would be 1 divided by, now let's see, what's the denominator going to be? The denominator is going to be how many have B and C in them, right? So B and C, 1, 2, 3. So we have a 1 divided by a 3 for our confidence for that one. Okay, now lift, you see that, you're going to have to find the support of a bunch of things and then put that into the formula to get the lift. So I won't do that. I won't show all of what we would have there, but I mean, as far as, I won't show you how we get it, but you just would use this lift formula. So you're going to have 10 over 9, 5 over 6, 5 over 6, and 5 over 9. So if I were to ask, what could we say? Would we say that it's likely that D would be bought given that A is also being bought? Well, that one is this first one, A pointing to D. How likely is it that D would be bought given that A is bought? Well, the lift is 10 over 9, so that's over 1. So yes, it is likely. For these other three, we would say it's not likely. It's not likely that A is going to be purchased given that C is purchased. It's not likely that C is purchased given that A is purchased. And it's not likely that D will be purchased given that B and C will be purchased. So remember that then. So on that right-hand column, for the lifts, it's only the ones that are greater than 1 where we would say that's a likely scenario. So that's it for this lesson, and you have a lab to complete. There are 2 parts to this lab. The first one is to find the support, confidence, and lift for a particular situation. In this case, it's buying diapers given the fact that milk is also being purchased. So we have milk and then an arrow to diapers. And you see these transactions down below here are the transactions that we're talking about. Okay, so you want to find support, confidence, and lift for that situation. Now, this one has words instead of letters or numbers. All of our examples before just had letters or numbers. So in order to keep from having to write out bread and diapers a bunch of times or milk or whatever, you might want to label them. There's 2 of them that start with B, but maybe you could label bread as BR, and then you'd have M for milk, D for diapers, and then just a plain B for beer, and then E for eggs, and C for cola. Anyway, however you want to do it, but that'll help to not have to keep writing the same words over and over. Although for your final answer, definitely be sure and tell me in terms of milk and diapers as opposed to M and D. Okay. So the first part is to find those measures, and the second part is to use the a priori algorithm to find all of the item sets with a support of 50% or higher. So just like what we did for the in-class activity and my other examples there, use that a priori algorithm and show me item sets with a support of 50% or higher. So go ahead and do that. You can either print out the paper, write on it, and then take a picture or scan it and submit that to Canvas. Or you can take the Word document that I have posted and just type in your answers. But if you type in your answers, make sure you aren't just including the answers, because I do say there I want you to show all steps and calculations. So definitely, if you are typing it in, be sure and show me how you get all of those answers, because I know that you would show me that if you were writing it down. It's just it'd be a little harder when you're typing it in, so just don't forget to do that. If you do it that way, if you type it in, then of course you don't have to scan it or take a picture. You can just save it and submit the Word document. But might be easier if you do happen to, and if you don't have a printer, I'll tell you what, here's another option too. If you don't have a printer, you don't have to actually print out the actual problem itself, but if you would like to write the answers down, just take a blank piece of paper and just say part 1, or first of all label it Association Rules Lab, then say part 1, and then show me your work, and then part 2, show me your work, but that way, and then take a picture of that. So that's another way to do it. Okay, good luck, and that's it for association rules.